electronegativity. Carbon is a strange element whose electronegativity depends on the type of hybridized state. Always sp3 hybridized carbon is less electronegative than sp2. sp2 is less electronegative than sp. In other words, whenever carbon undergoes sp3 hybridization, it has 25% s character. In sp2 hybridized state, the carbon has a 33.3% s character. In sp hybridized orbitals, there is 50% s character. As the s character is increasing, the electronegativity is increasing. See, if you take fluorine, its electronegativity is always 4, much greater than that of carbon. If you take oxygen, its electronegativity is 3.5, much greater than that of carbon. If you take chlorine or nitrogen, their electronegativity is 3, much greater than that of carbon. But if you take chlorine, bromine, iodine, all these fellows have more electronegativity than carbon. But the carbon electronegativity itself depends on the type of hybridized state. Please remember, whenever carbon is making only single bonds, it is sp3. Single bond forming carbon is least electronegative. Double bond forming carbon on any side is more electronegative. Carbon that makes 2 pi bonds, that is a triple bond, is most electronegative. This carbon auntie is sp2. The carbon boy is sp. The carbon C is sp2. If you take a molecule like this, identify the hybridized state of each carbon. Hybridized state of A carbon and E carbon is sp3. B carbon and D carbon is sp2. C carbon is sp. So this is the order of electronegativities. A, E is less than, B, D is less than C. There is a standard question about electronegativity of carbon. Next. What is the general formula of alkynes? A simple question. Alkynes is a homologous series. The general formula of this family members is CnH2n minus 2. What is the general formula of alkenes? CnH2n. What is the general formula of alkanes? CnH2n plus 2. What is the general formula of alkanols or alcohols? CnH2n plus 1 OH or CnH2n plus 2 O. Like that, there can be questions related to general formula. Aldehydes or ketones have general formula, like both have same formula, CnH2nO. These compounds, like alcohols, like ketones, they all can show functional isomerism. But if I have alkyl bromide, alkyl halides, the halogen is no status of functional group, so alkyl halides can never show functional isomerism because they don't have any functional group. That's the problem. That is one point I wanted to discuss with you. Now, another point I want to discuss with you is, what is an acid? What is a base? On this point, I want to talk to you today. We will be doing it very slowly. Don't worry.
Hi.
Yes. An acid is a substance.
Hi.
Hi. Hi, Andava. Pillata antava. And just you wait. Very good. Very good. An acid is a substance H plus and Cl minus. Let us take another acid, sulfuric acid. No good, huh? Good. Sulfuric acid is also an acid that gives H plus and HSO4 minus. Anybody who can give H plus can be called as an acid. Proton donor is an acid. Whenever a H plus is coming, you are also getting something which has a negative charge. That which has negative charge is called its conjugate base. Always an acid gives conjugate base with a negative charge after using H plus. Now can you think what is the conjugate base of water? What is the conjugate base of water means OH minus is conjugate base of water. Because after giving H plus, it gives OH minus. Can you think what is the conjugate base of acetic acid? Conjugate base of acetic acid is acetate ion. Notice, an acid is an excellent acid if it can most readily give H plus. It can most readily give H plus if the conjugate base is stabilized. If you are looking at water, its conjugate base is neither stabilized nor destabilized. If the conjugate base is stabilized, it becomes good acid. If it is destabilized, it becomes poor acid. Sir, what is the factor that stabilizes the conjugate base? Conjugate base has negative charge. Charge is a burden or a nuisance. Any factor that removes the burden or any factor that removes the negative charge, any factor that decreases the negative charge, stabilizes. Any factor that increases the negative charge, whether it is a negative charge or positive charge, any factor that increases the charge makes it unstable because charge is a burden. Therefore, any factor that stabilizes the conjugate base is a factor that takes away minus charge. To take away minus charge, you have two schemes. One is using an electron withdrawing group. Any group like NO2, CN, C6H5, all these groups which have minus I effect, electron withdrawing inductive effect, if they are there, they can take away negative charge. At the same time, if this conjugate base has any electron releasing group, like methyl, like ethyl, like propyl, electron releasing groups will increase the negative charge. So all plus I groups make a acid weak acid. Let us explore this. Also, minus charge or plus charge can be removed, can be dispersed through resonance. When resonance can happen, whenever a charged atom, minus charge, single bond, double bond, single bond, double bond, like that if there is a system, or plus charge, single bond, double bond, single bond, double bond, the system is said to be in conjugation. Due to conjugation, there happens resonance. Due to resonance, plus or minus charge can be removed. Therefore, any factor that will take away the negative charge stabilizes the conjugate base. So anything that stabilizes conjugate base makes an acid better acid. Hi. Now we are very clear about it. Now let us look at some compounds and decide which is a better acid. I have water. I have ethyl alcohol. I have phenol. I have acetic acid. Auntie, boy, chutney, donkey. Okay, let us take formic acid. It makes no difference. Now, which is a better acid in A, B, C, D? Let us try to apply our idea. To decide which is a better acid, first we work out the conjugate base. Any acid gives H plus, any acid gives H plus, any acid gives H plus, it also gives H plus. Along with H plus, it gives OH minus. It gives CH3, CH2, O minus. It gives phenoxide ion, O minus. It gives HCO, HCO, O minus. So all are giving minus ion. In whatever the case minus ion is stabilized, that it is a better acid. Let us examine. In water, there is neither stabilization of OH minus nor destabilization, no factor. In ethanol, the nature of ethyl group, the nature of methyl group, the nature of tertiary butyl group, like any alkyl group, is releasing electrons by inductive effect. As the alkyl group is releasing electrons by inductive effect, plus I effect, the negative charge on therefore, the ethoxide ion is destabilized by plus I effect of alkyl group. Hence, ethoxide ion is not forming readily. Therefore, ethanol is a very weak acid when compared with water. Why ethanol is a weak acid when compared with water? Ethanol is a weak acid when compared with water because the conjugate base formed for ethanol, ethoxide ion, is destabilized by electron releasing inductive effect plus I effect. Now let us look at the phenol. In phenol, there is a phenoxide ion. The phenoxide ion has a minus charge on oxygen, and if I examine minus charge, single bond, double bond, single bond, double bond, single bond, double bond, single bond. Therefore, the negative charge can be dispersed into the system by resonance. If the negative charge is coming between O and C, the pi bond will go there. Because carbon cannot make 5 bonds. You can't keep a structure like O double bond, C double bond. No. Now the negative charge has shifted from oxygen to carbon. Again, if the negative charge is coming in between these two carbons, the pi bond will become negative charge. So next thank you. Now, you have next canonical structure like this. Again, the negative charge can come in between these two carbons and pi bond can go over there. Finally, the negative charge comes here and oxygen becomes negative again. So how many resonance canonical structures I could write? 1, 2, 3, 4, 5. The phenol gives a conjugate base phenoxide ion. The phenoxide ion is having 5 resonance canonical forms in which the negative charge is distributed between oxygen and carbon. This resonance is definitely going to stabilize the phenoxide ion. Therefore, definitely, by all means, phenol is a better acid than water, than ethanol. In ABC, phenol is a better acid than water. Water is a better acid than ethanol. Ethanol is the worst acid because the conjugate base in oxide ion is destabilized. Phenol is a better acid because the phenoxide ion is stabilized by electron withdrawing resonance effect minus R effect. No, it is electron withdrawing resonance. I would say electron withdrawing resonance means plus R effect. Electrons are going into benzene system, into carbon system. If electrons are going into carbon system, you should use plus sign. If electrons are going away from carbon chain, you should say minus sign. So it is plus R. Anyway, notice that the resonance between different atoms, oxygen and carbon, definitely is there, but the carbon being less electronegative is not really interested to keep negative charge. Now let us compare the resonance in the formate ion. In formate ion, you can see negative charge, single bond, double bond. Therefore, it can go there, it can come here. Here there are two resonance forms, C and B, but both are identical because in both cases, oxygen is holding negative charge. Oxygen being more electronegative allows to keep negative charge, it allows to play the game. So, though the resonance canonical forms only are two in formate ion, but the resonance is more effective than in phenol. Because in phenol, negative charge is going between oxygen and carbon, carbon less electronegative. Hence, the resonance effect is very serious in case of formate ion. Hence, it is greatly stabilized. Therefore, formic acid is more acidic in this. One second. Formic acid is more acidic than phenol. Phenol is more acidic than water. Water is more acidic than ethanol. That is the order. Can you see this order clearly? The correct order of acidic strength, I repeat, D is more acidic than C. C is more acidic than A. A is more acidic than B. For your information, I want to compare CH3COOH, HCOOH, phenol, anti by chutney. Name of this is acetic acid or ethanoic acid. Name of this is formic acid or methanoic acid. Name of this is phenol. Now, in these three, which is more acidic? Our rule is same. Wherever conjugate base is more stabilized, that is a better acid. Wherever conjugate base is destabilized, that is a bad acid. I am comparing. Acetic acid gives acetate ion and formic acid gives formate ion and phenol gives phenoxide ion. Definitely the acetate ion and formate ion are resonance stabilized, and the resonance is happening between identical oxygens. So resonance effect of acetic acid and formic acid is more than that of phenol, because in phenol resonance is happening between oxygen and carbon, which are different. Definitely C is least acidic in A, B, C, because whenever you compare carboxylic acid with other something like phenol or alcohol, they are less acidic. The acids are more acidic. Now in these two, A and B, which is better acid, we have to see. Notice both carboxylate ions are resonance stabilized, but here in acetate ion, the methyl group is electron releasing in nature by inductive effect. Because it is releasing electrons, the negative charge burden is increasing. In formate ion, there is no such problem because hydrogen is neither electron releasing nor electron withdrawing. Therefore, in acetic acid and formic acid, the acetate ion is somewhat destabilized by plus psi effect. There is no such problem in formic acid. Hence, formic acid is a better acid than acetic acid. So the order of acidic strength, B is more acidic than A is more acidic than C. Now let me repeat this idea. An acid is one who can give H plus and a conjugate base. Conjugate base has negative charge. Any factor that increases the negative charge makes it unstable. Any factor that decreases the negative charge makes it stable. Electron withdrawing groups make an acid better acid. I will write in capital letters always electron withdrawing groups like NO2, CN, fluoro, chloro, C6H5, etc. increase acidic strength. The electron withdrawing groups EWG decrease negative charge on conjugate base and stabilize it. Hence, they increase acidic strength. Sir, if you have acetic acid, trichloroacetic acid, anti and bi, which is better acid? Here you get a conjugate base like CH3COO minus. Here you get a conjugate base like CCl3COO minus. Sir, the nature of Cl is electron withdrawing by minus psi effect. So they strongly withdraw the electrons so that the negative charge is greatly decreased. So trichloroacetic acid is a million times better acid than acetic acid. In acetic acid, methyl group is electron releasing in nature, whereas trichloromethyl group is electron withdrawing in nature. So trichloroacetic acid, B is in million times better acid than A. Are we very clear about it? So rule of the thumb, always alcohol is weak acid than water. Why? In water, conjugate base is not destabilized. In alcohol, conjugate base is destabilized by electron releasing inductive effect of alkyl group. Now, alcohol is represented by ROH, or can be methyl, ethyl, propyl, butyl, pentyl, so on. RO minus is called alkoxide ion. It can be methoxide, ethoxide, propoxide, butoxide, so on. Generally, alcohols are less acidic than water because alkyl group destabilizes the alkoxide ion. Always alcohols are less acidic, weakly acidic than water. But phenols, where the OH is linked to benzene, phenols are different from alcohols. In alcohols, OH is linked to alkyl group. In phenol, OH is linked to benzene. Phenols are more acidic than water because phenoxide ion is greatly stabilized by resonance. Always carboxylic acids are better acids than phenols because carboxylic acid gives carboxylate ion, COO minus ion. Resonance is between identical atoms. When the resonance is happening between identical atoms, resonance effect is more. Next, we have discussed about acids. We all agreed upon that acid is a substance that can give H plus. Sir, if I have CH4, CH3Cl, CH2Cl2, CHCl3, which is a better acid? Auntie, boy, chutney, donkey. Better acid. Obviously, CHCl3 is a better acid because the negative charge is lowered by electron withdrawing Cls, which are 3 in number. So D is a better acid than C, C is better than B, B is better than A. Can CCl4 be acidic? Answer is no. Why no? An acid is one which can give H plus. It has no H plus to give. So CCl4 is not acidic. Those Cls are more. Be careful. We talked about acids. We got an idea that an acid is one which gives H plus. It can give H plus only if its conjugate base is somewhat stabilized. If the conjugate base is stabilized more and more, it is becoming better and better acid. Suppose if I have H of HCl, HBr, HI, which is a better acid? If I look at conjugate base, the negative charge is dispersed in a large iodide. Iodide ion is biggest in fluorine, chlorine, bromine, iodine. Down a group, the sizes increase. When the negative charge is distributed over large volume, negative charge density becomes less. In fluoride ion, negative charge is present on small fluoride ion. Charge density is more. Any factor that decreases the charge or charge density makes it stable. So, iodide ion is greatly stabilized than fluoride ion as charge is dispersed. Hence, HI is a much better acid than H. Not only here in any group, down a group, in hydrides, acidic strength increase. Now, bases. A base is one, as you are saying, anybody who gives H plus is an acid. Anybody who takes H plus, who gains H plus, who can take H plus is a base. This concept which is saying an acid is one which gives H plus, a base is one which takes H plus is called proton concept or Lowry-Bronsted concept. So a base is one which takes H plus. After taking H plus, you are getting a positive ion called conjugate acid. So whenever you are adding H plus, you get a conjugate acid. Whenever you are removing H plus, you are getting a conjugate base. This idea is very, very important. For anybody, if you are removing H plus, If it is giving out H plus, a fellow who is H plus releaser is an acid. After releasing H plus, it gives after releasing H plus, you are getting conjugate base. More stable the conjugate base is, more acidic the material is. After gaining H plus, anybody gives conjugate acid. Even more stable the conjugate acid, better base it is. Can you think of this? If you are having H2CO3, what is its conjugate acid? Its conjugate acid is HCO3 minus ion, because you have to remove H plus. Now, what is the conjugate acid of bicarbonate ion? Bicarbonate ion can again lose one more H plus and can give you carbonate ion. Now there is a question. If I take bicarbonate ion, what is its conjugate acid? To get conjugate acid, you add H plus. To get a conjugate base, to get a conjugate acid, you add H plus. To get a conjugate base, remove H plus. That is the rule I think you can remember. Always you can add H plus to get conjugate acid. Always you can remove H plus to get conjugate base. If you are getting conjugate base means the fellow is losing H plus, it means it is acting like acid. If you are getting conjugate acid, it means this fellow is added with H plus, gaining H plus, so it is acting like base. In this way it is behaving like base, in this way it is behaving like acid. So some materials can behave both the ways, as acid as well as base. Anyway, now let me look at this idea. Which is a better base? Ammonia, methylamine, dimethylamine, auntie, boy, chutney, donkey, aniline. Aminobenzene is called aniline. Which is a better base? We said the base is one which can take H plus. It can take H plus only if it can release the electron pair. It has a lone pair, that is donating. It has a lone pair, that is donating to H plus. It has a lone pair. It has a lone pair. In each case, these fellows are taking H plus. Yes. The question is, who will take H plus most readily? That fellow who has more electron density on nitrogen can take H plus readily. The electron density is increased by methyl group plus I effect. Here the electron density is increased by two methyl groups because there is more plus I effect. Therefore, in ABC, C is a better base than B, B is a better base than A. Now let us look at D. In D, we write D separately. In D, aniline, the lone pair, single bond, double bond, single bond, double bond, single bond, double bond, single bond. This resonance possibility can take away the electron pair into benzene due to plus R effect. As a result, the lone pair on the nitrogen is disappearing. The lone pair is not available means it cannot donate to H plus. We can write 5 canonical forms. In all these canonical forms, you will notice The lone pair is engaged in making a double bond, distributing negative charge on carbons. You can write one more. Because the lone pair is disappearing as it is flowing into benzene in aniline, it is not available for donation. Hence, aniline is a poor base. Aniline aminobenzene is a weaker base because the lone pair of electrons are taken away by resonance effect. Hence, any electron withdrawing group makes a base bad base. Any electron releasing group makes a base better base. Releasing groups are methyl, ethyl, propyl, butyl, so on. Any electron withdrawing effect decrease the base strength. Any electron releasing effect increase the base strength. Notice, for whatever we said for acid is opposite for base. For acid, I said electron withdrawing group makes acid better acid. For base, opposite is true. Electron withdrawing group makes base poor base. Therefore, if you remember one side of the story, other side you can construct. Finally, I want to look at another idea. Aniline, cyclohexylamine, ammonia, pyridine, anti, boy, chutney, donkey. In these four, which is a better base? Can you think? And say the answer. You can put the answer in chat box. In A, B, C, D, which is a better base and why? Before you answer, I want to say one thing. Any cyclic system like benzene that has double bond, single bond, double bond, single bond, double bond, single bond, a cyclic system with alternate double bonds can have resonance. Due to resonance, benzene is getting extraordinary stability. To get that extraordinary stability in a cyclic system, double bond, single bond, conjugated system, we use a term called aromaticity. Aromaticity is a term that indicates stability due to resonance in cyclic systems. Aromaticity means extraordinary stability. The cyclic systems which have alternate double bonds, single bond, etc., they are getting aromaticity. There is a rule. The rule is any cyclic system that has 4n plus 2 pi electrons is aromatic. For example, in benzene, n is equal to 1 and benzene has 6 pi electrons. There are 3 double bonds. Each pi bond is 2 pi electrons. So any cyclic system that has 4n plus 2 pi electrons is aromatic. Benzene is aromatic, very stable. I say cyclic systems which have alternate double bonds are aromatic. To be aromatic, it should be a cyclic system with 4n plus 2 pi electrons. Now, if you look at this compound called pyrrole, it has 2 double bonds. Double bond, single bond, double bond, single bond. Lone pair, single bond, double bond. Again, it's double bond, single bond, double bond, single bond. Lone pair, single bond. This is also in conjugation. To get aromatic stability, it also requires 4n plus 2 pi electron called Huckel rule. If n is equal to 1, it requires 6 pi electrons. But it has only 2 pi bonds. 2 pi bonds means 4 pi electrons. In order to get aromaticity, it requires 6 pi electrons. So it will take away those 2 lone pair of electrons also for aromaticity. So these 2 electrons are involved in aromaticity. And due to the aromaticity, pyrrole is getting stability. Because the lone pair of electrons on nitrogen are locked in aromaticity, they are not available for others. If it cannot give lone pair to others, it is not basic. So pyrrole is not at all basic. What is a base? Base is somebody who can give lone pair to H plus. Why pyrrole is not basic? Because in pyrrole, the lone pair on nitrogen is not free. Why it is not free? It is involved in aromaticity. Why it was have to involve in aromaticity? To be aromatic, cyclic systems require 4n plus 2 pi electrons. If n is equal to 1, it requires 6 pi electrons. If these 2 electrons are nitrogen are also participating, it gets aromaticity. So pyrrole is a worst base and ammonia is a base. Aniline is a poor base because the lone pair is withdrawn by resonance. Therefore, pyrrole is worst base. Then A is a bad base. Then C. Cyclohexylamine. Cyclohexyl group is alkyl group that is electron releasing in nature. Due to the electron releasing nature of cyclohexyl group, cyclohexylamine is a better base. Therefore, the order of basic strength is obviously B is better base than C. C is better base than A. A is better base than D. D is worst base because the lone pair is fully engaged in aromaticity. A is a bad base because the lone pair is withdrawn by resonance. B is a better base because the electron density is increased by electron releasing nature of cyclohexyl. So these are typical IIT mains model questions. They give you a compound and ask you which is better acid, which is a poor acid, which is a better base, which is a poor base, etc. The acidic strength, basic strength can be understood by considering inductive effect, resonance effect in systems. Summary. An acid is one which gives H plus. An acid is a better acid if its conjugate base is stabilized. Conjugate base is that which has minus charge. Conjugate base is stabilized if there is an electron withdrawing group. It is destabilized if there is electron releasing group. Opposite is true for bases. This discussion is not there in NCERT book. Because it is being asked in IIT mains in advance, I made a discussion. For your examination, syllabus is up to this point. IUPAC nomenclature, inductive effect, resonance effect, electromagnetic effect, hyperconjugation. Thank you very much. We will be meeting again on Monday. If you have any difficulty, please WhatsApp your difficulties. I try to support you with YouTube videos. Thank you very much.